Hey everyone, how's everyone doing? We're going to look at balancing chemical equations. Now, we're not going to do every one of these. I'm just going to pick two of them to do. Let's say number 1 and number 4. Just want to look at giving you an idea of how to do it, but I will post a whole page for those of you that may want to try a couple of them and see how you do. I suggest that if you're trying them, go with like the easier ones. Don't try to get complicated. Like don't do number 5 or number 6. But I would stick with stuff like 7 or 8 or something like that. Maybe 2 or 3. You just want to get a feel for it. That's all. So what we're going to do is we're going to start with the first one. It says blank N2 plus blank H2 yield. That's what that sign means. Blank NH3. Now the way this works is each one of these capital letters or a combination of a capital and a lowercase letter represents an element on a periodic table. So this represents nitrogen, this represents hydrogen, and then this is the combination or the chemical reaction that you get when you mix nitrogen and hydrogen together. So what we're trying to do is we're trying to figure out how to balance it off on both sides. So let's look at the paper, right? So if I took that problem, what I want to do to start this off is I'm going to put a line down the middle. The reason why I'm doing this is so that you know that this is one side of the chemical equation. This is the other side of the chemical equation. So when I balance it, what has to happen is I have to have the same values on both sides of the equation. That's what I have to have. Kind of like in math. So it's the same thing. Now, a quick rule to remember is that when you're balancing chemical equations, you cannot change the numbers that are here. You can't change these subscript numbers. But you can add a coefficient or a number in front of the values, but you can never change these values, but you can add a coefficient in front. Now, another thing to remember is that whenever I add a number in front, I'm multiplying by the number that I already have. So there's no real adding or subtracting going on. It's really multiplication. So first, let me look at what I have. According to this, on this side of the equation, I have 2 units of nitrogen. That's what that tells me. And over here, I have 2 units of hydrogen. This is what it's telling me. On this side, I notice that I have only 1 unit of nitrogen and 3 units of hydrogen. Because again, anytime there's a capital letter, that's the beginning of an element. So then I have 2, 2, 1, 3. That's not balanced, right? So I want to make it balanced. Well, because I have this 3 here of hydrogen and I have a 2 here of hydrogen, I'm going to start with those because I want to balance those first to me. And the only way I'm going to balance this is I have to find something I can multiply by both of these numbers that my end results will be the same. Well, if I'm thinking about 2 and 3 and I'm going through my timetables, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. If I go through my 3 timetables, 3 times 1 is 3, 3 times 2 is 6. Well, 6 is the first value that they have in common. And in order to get 6, I know that I would have to multiply 2 by 3. So I'm going to put a 3 here as my coefficient because 3 times the 2 I already have is going to give me 6 so far. Well, if I did that here, then over here I need to change this one as well. And I'm going to say 2. Now, remember, these are already connected. So this 2 has to multiply by this 1 as well as this 3. So I'm distributing it. So 2 times 1 would make this become a 2. And again, it's multiplying, multiplying, multiplying. And then this 2 times this 3 would make this a 6. So now, am I balanced? Well, I have 2 nitrogens here. I have 2 nitrogens here. I have 6 hydrogens here. I have 6 hydrogens here. So far it's balanced. So my final result would be Na. I don't put any value there because I don't need any. N2, sorry you guys, plus 3H2 yields 2NH3. That would be my final answer to that particular problem. Make sense? I hope so. All right, let's try another one. So another one that we had on the paper was H2 plus O2 yields H2O. So we know H represents hydrogen, O represents oxygen. This is the yield sign. and we split. Now, you guys, if you don't know what these H and O and the capital letters mean, it's okay. You can still do this because you don't have to know what the abbreviations stand for to do it because you're focusing on the numbers. So you're still fine. So far I have 2 hydrogens and 2 oxygens on this side. On this side, I have 2 hydrogens and I have 1 oxygen. Well, if I look at this, hydrogen and hydrogen is already balanced, so that's not the problem for me right now. It's the oxygens that have an issue. I have 2 oxygens on this side, but I only have 1 oxygen on this side. So the only way to get this to balance is to make a coefficient of 2. Well, what happens when I do that? That means 2 times this 2 would give me 4. And 2 times this 1 would give me 2. But when I did that, yes, my oxygens balanced, but it threw my hydrogens out of balance. So in order for me to get my hydrogens to balance, I would have to multiply by 2 here because 2 times 2 would give me 4. So now I have 4 hydrogens, 4 hydrogens, 2 oxygens, 2 oxygens. Now, y'all, this plus sign means, of course, that I can't take this 2 and multiply it over here because that's a plus sign, so it only goes with that. You know, the reason why I have to do it here, because you notice there's no sign between it, so it does go with both values. So my final answer would be 2H, hydrogens 2, plus oxygen 2 yields 2H2O. Okay? All right, like I said, I will post this as well as the rest of them. You can try a few, let me know. And hopefully it works out for you. Again, don't try to do all of them. Just pick a couple. Just make sure you understand it. That's really what it's about. All right, you guys. Bye.